Rafiziana, you can start now.
Oh, okay. Hi. Assalamualaikum warahmatullahi wabarakatuh and good morning. Today we will have another session on the Distinguished Lecture Series number 83 with Professor Emeritus Soonhung from KAIS. I will be the moderator for today. My name is Rafiziana Makasmani from School of Chemical and Energy Engineering. Basically, I know Professor Hans when we were both invited to become a keynote speaker for International Symposium on Mechanical Engineering 2017 in Pias, Pakistan. And from that, we will kind of like have a very good, be a good acquaintances in France because we were together for about like a week. For this session, okay, back to the lecture series. For this session, Prof. Han will give talk around 1 hour, and we will have a Q&A session at the end. So appreciated for the audience today, if you could type your questions to be asked earlier in your chat box. If you don't want to miss an opportunity to be answered by Prof. Han. I think that is a brief introduction, so I hand over to Professor IR Datuk Rafiq for Prof. Han bibliography before he starts his lecture today.
Thank you, Rafiziana, for chairing the session. Assalamualaikum warahmatullahi wabarakatuh. Welcome everyone. Welcome to our 83rd UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq and I am the Dean of Engineering University Technology Malaysia. Today it is my utmost pleasure to welcome Professor Emeritus Soonhung Han from Korea Advanced Institute of Science and Technology. A bit about our distinguished speaker today. Soonhung Han is a Professor Emeritus of the Graduate Program of Ocean Systems Engineering of the Department of Mechanical Engineering of Korea Advanced Institute of Science and Technology, KAIST. He is leading the Intelligent CAD Laboratory of KAIST, the STEP Community of Korea, ISO TC184 SC4 JWG16 Visualization of Product Data, and the Korea ICT Convergence Network. His research interests include STEP, which is the ISO standard for the exchange of product model data, VR for engineering design, and knowledge-based design systems. His domain of interest includes shipbuilding and automotive. And you can find more information from his personal webpage that can be found from our Faculty of Engineering Facebook page. So that is a brief biography of our distinguished speaker. Here now is Professor Emeritus Soonhung Han from Korea Advanced Institute of Science and Technology with a talk entitled ISO STEP Standards and the Use of Virtual Reality in Shipbuilding. Professor Emeritus Soonhung Han, over to you.
Thank you, Professor Rafiq. This is Soonhung Han. Hi, let me share my screen this way. And also, there are several steps. Okay. I hope you can see my screen now. And this one is my slider. I'm ready. Hello, everybody.
Yes, slides, yes, thank you.
Apa kabar? I hope it is Malaysian law.
Khabar baik, Prof.
And my title has three short names or abbreviations. So I will explain about this one a little bit more in my talk. So this one is my bio. Professor Rafiq already explained me. So I will skip over this. And you can see in the later stage, I will provide this slide set after my talk, so you can see more from the slide set. So this is a website of KAIST, where I belong. It's a university, very similar to UTM. So we may have a better collaboration in the future. So my talk is divided to 3 parts. One is ISO step, and then VR. Probably you heard about VR several times, so I may be short on what is VR. But my main topic will be VR application in shipbuilding industry, probably in Korea and around me. So this is a history of design of any mechanical part or engineering design in bigger scope. So in say 20th century, there was no computer. So there is a physical model made by hand, and then it comes with drawings, probably paper drawings until 1960s. And then it comes with a computer. So computer provides us a new way of describing the drawings into. So you can imagine the AutoCAD. So AutoCAD replaces paper drawings. And nowadays, everything goes to 3D and even VR, right? More than 3D. So final stage, we can say intelligent product data. Then I can reproduce as a combination of AI and digital twin and big data is coming. Right? That is a new word in these days, I guess. And this one is a cover page of the report coming from Germany about the Industry 4.0. They produce many reports about Industry 4.0. One of them is standardization roadmap. So they are claiming that standard is important, even more important than before for the Industry 4.0. So why we need a standard? You may think about this or the historical idea of Babel Tower. So basically, standard is for communication. Right? Communication between human, also communication nowadays between robots or between devices or computers or softwares. One example of this one, this is coming from automotive industry of United States for more than 10 years ago. They tried to exchange design data between companies. So Chrysler is as a final maker of the car. Nowadays, Chrysler is merged into Daimler-Benz, I guess. And then they order or outsourcing parts from Delphi Saginaw. Saginaw is a city name in Michigan of United States. And Delphi is a company under the GM. So GM and Chrysler is different automaker, but they can provide parts each other. So steering pump and steering column and steering gear is purchased from Delphi. So they order and deliver, and drawings for the ordering and delivering and making, they need to exchange drawings of pump and column and gear. Now, the Delphi Saginaw also had a subcontractor called Jovamax. They use further divided smaller parts. So we call this way as OEM and first tier supplier and second tier supplier. So we all are saying this is a supply chain management, something like a pyramid. But in this way, each company use different CAD system. CATIA is a very famous CAD system nowadays, and UG is now owned by Siemens, originally coming from GM, but they transferred or merged into Siemens of Germany now, so they have a different name now, but still use UG. And then Jobamax is a probably small company. They use AutoCAD, but it's small, but cheaper software. So problem is, how can they share this drawing or CAD model between three organizations? So we need a standard. So this is organizational structure of ISO TC 184. They are handling of automation of manufacturing, so automation system. And they, under them, there's 3 subcommittees, SC, and 1 working group. And subcommittee 1 is for numerical control machines, drilling machines. And then SH4 is I belong to is industrial data. They handling design data or CAD data, CAD data. And SH5 is for shop floor. At the plant shop, there are many devices, including NC machine, robots, and conveyor belt, and crane. So they need the communication between those devices. So SH4 has more working groups. I will not explain all of them, but I'm working on the green color, the JWG16 for visualization. Okay, next slide. So there is a website for explaining about what is SH4 working on, industrial data. So you can visit sometime if you are further interest. And also, I provide several times of classes on talking about STEP standard. So last one is for 2016 inside KAIST in Korea, but it is uploaded on the Google. So you may have a more interest. You can visit that website to get more information. Also, the lecture is uploaded and captured as a video and uploaded in the YouTube. So the same class. So you may have a time to look at some of the classes. All right. So because I'm a convener of JWG16, I will explain a little bit more on this. And there are 6. It is JWG16 is a little bit relatively new organization or working group inside ISO, only 2 years old. So this is our first set of project, and step geometry service, and second is digital twin. Third one is PLM MES. PLM is a product lifecycle management. And MES is short name of manufacturing execution system. So those two, second one, digital twin and PLMS, is my own project. So I'm the project leader of these 2 projects. And JT is coming from UG or Siemens. So they standardize their own CAD files. So it is under the leadership of USA as UG company and Germany as a Siemens. The other one is industrial requirement. They are collecting industry requirement for the visualization in this technical committee. And final one is a Collada. Collada is another standard coming from Kronos group. So it's that. So this one about digital twin I'm working on is just published this month. The first TR means technical report. So under this digital twin, I'm categorized in 3 subgroups. So physical twin, digital twin, and interface between them. Right. Drawing or design. The purpose or target of the drawing or target of the design is for machining or manufacturing. That's why the drawing should have all the details of how to manufacture, how to machining the piece. Right? So Nist is a United States standard technology institute for National Institute for the Standard and Technology. And they provide step file analyzer or software and also viewer, right? So under the screen, you can see that picture of some part, looks like a battery, something. And they use a Nist software to show the part. And right-hand side, you see that X3D. X3D is coming from Web 3D consortium and Open Cascade, also the CAD system, and HTML5. That is that provides a capability for 3D visualization. And here is one simple video. Let's see this. This is about numerical machining, NC, numerical control machining demonstration using step. Let me see.
Series of technology demonstrations and technical meetings showing the work being done on STEP NC and other related topics to create smart data for smart machining. This meeting focused on feed speed optimization, measurement, and closed-loop feedback of the measurement results to machining. The test part for this demonstration was a 6.3-inch titanium impeller, which was machined live at the meeting. Before the meeting, the team constructed a complete STEP NC machining program for the impeller. As you can see, the STEP NC description contains a CAD model of the final result. A CAD model of the initial stock, as well as CAD models of the fixtures and cutting tools used by the process. The machining process was from tool paths originally generated by the Concepts NREC Max 5 system, which specializes in turbo machinery. From these, a series of STEP NC work plans and individual working steps were constructed for roughing. Although the original tool paths described just one blade, they were reused by the STEP NC working steps to describe each of the 8 blades without taking any more space. The file also contains similar work plans for semi-finishing in bytes. The STEP NC machining description is machine independent, and the same data was used for machining both on the DMG Evo 70 at the C.
Let me stop here. Can return back to. So there is a link to this video, so you can see all the detail later. All right, let's move on to VR section. So Avatar is a very famous film, which explains what is a VR. So you can imagine what can be used and used for VR technology. And here is one or another video which shows advantage of using VR or AR. AR is the probably same person. Use at the left-hand side, he use paper drawing to assemble wiring of electronics or fixing some wiring. But in right-hand side, he is using a glass goggle. And at the goggle, the display allow him to see the contents of the paper drawing. So he did not need to see the paper drawing. So they are trying to calculate the difference between them. Let's see. So left-hand side, he's looking at paper drawing to see the correct cabling, wiring, connections. But right-hand side, he did not use paper drawing. He used a glass goggle, but he need some parts to collect to use. So, and then he found that the percentage of timing. So that is it. How we will use VR technology or AR technology for the real industry. Right. This is coming from another standard organization and working on AR. And you probably know about Pokemonster game. And they use a real picture and together with a virtual object together to create a game. So inside that game, how can we organize the components and concepts inside there? So at the top, you see that real root and virtual root. So it looks like a digital twin. Here, and old days, it is a kind of a power plant control room. So when you visit the power plant, which create electricity, produce electricity, there is a control room which can see all the details, all the overview of the machining around the whole plant. So there are so many switches and panels and displays, so they can control each of them. So this is old style, you can say analog style control room. Nowadays, they changed into a digital control room like this. So all the analog switches and displays are replaced by screens, monitors. Right? And then also at the desk, also there are small monitors, many monitors and keyboard instead of real buttons and dials. So we can say that analog to digital conversion or digital transformation. In ocean engineering, you can see that there is also digital twin or digitalization. So at left-hand side, there's a real physical plant operating in the ocean, but that ocean is far away. So nobody wants to stay there. So instead, in the bottom, you can see that operation center is inside the office. Many people, most of people want to stay there, work there, instead of working inside the ocean. So that's created digital operation rooms here. So VR, AR, or digital twin can be used for this. And if we increase your scope of concept of digital twin, you can talk about digital twin of Earth. So right-hand side, you see that Google Earth. Google Earth is very nice to see. When I was visiting a Google company, I tried to find out my house in South Korea from the Google company. So then it can be digital and physical. And also IEEE is working on interface, probably IoT, sensor interface between cyber and physical. So at top level, there is a cyber world, and bottom level, there is a physical world. Between them, there should be some communication. Right? So you can see this is another digital twin. And moving more on to shipbuilding, this is slide coming from Samsung Heavy Industry inside Korea. They modeled engine room, backside of the ship, more detailed because they produce this ship. Right? They have all the detailed models and real physical models too. So very detailed model can be provided. And here is one slide, but I will skip over. They use digital model to make some operational demonstration. Aviva is a software company specialized in shipbuilding CAD system, shipbuilding CAD system. So they try to use a VR technology for the shipbuilding CAD. And ship is big, but to make it very fast, can say productivity, they make the big chunk of ships into one set. So they call this is a block, B-L-O-K, O-C-K, and make blocks outside of the shipyard, and they assemble inside the shipyard very fast. To make this fast, they need to have a handling of these big giant blocks of several thousand tons using a floating crane ship. They call floating crane barge at the left-hand side. Let's go on to final stage of VR in shipbuilding. Right. So ship is big. Right. I found that the Petronas Twin Tower is also big. So you can imagine that the building, the tower, the Petronas Tower is lying side by side. That is about the same size. The shipbuilding company inside Korea, the big one, something like a Samsung or Hyundai, they produce more than 60 ships per year. That means there are 52 weeks per year, right? So that every week there is one ship is constructed, delivered about this size. Right? Comparing to the Boeing 747, probably A380 of Airbus is a little bit more bigger, but about similar size, very small, right? Now, because the ship is big, comparing to similar to Petronas Twin Tower, they cannot produce mass production. If you think about making a car, in old days, like 1850, starting at the bottom, they produce the Benz, something like that. They produce car by several people for, say, several months or years, producing one car by one car. But about 1913, the Henry Ford created a mass production concept using conveyor belt. So at that time and until 1955, mass production is very popular. So say one model of a car, Hyundai Motors, they probably produce 500,000 or 500,000 car of same design. We call this is a mass production. Now, things are changing in these days. 1980s and 1994, they calling mass customization or personalized production. Personalized production means one by one or contract design. Very similar to ship or building. Petronas Twin Tower, there is no mass production of that building, right? One by one for several years. Right? Ship is same. So that we call this is a personalized production, is returning back to new style of production. Oh, here is another video. You need to see it. This is a VR. They use a 360 all around stereo. Right, comes.
Hey guys, before we begin, a couple things. First, check out the non-360 video. That one's more entertaining and gives a closer look. This
see that
360
surrounding
version is
view,
designed
right?
to be interactive and gives you more freedom to look around. Second, turn on 2K if you can. It's a see the SART, fire
Inside the
extinguisher,
pilot house.
the pantry for coffee and snacks. Some ships have microwave, but we don't. We've got an elevator that comes straight up. It's the green door.
Looks like this one. Let me stop here. So we call this is a panoramic view. So it is coming to YouTube already using a VR camera cam. And this is a kind of digital mock-up or digital model of engine room of a Navy ship inside Korea. And also digital mock-up of the same ship probably. And there is another 300 panoramic view of VR. And that is a shipyard of Turkey. They just launching a new ship. So I'll skip over. There is not enough time. You can see. And one new technology is coming is a laser scanner. And so they produce point cloud. So Faro is one of the company. They produce a laser scanner for the building and for the ships. This one is a very big ship or ocean plant. They capture all of the big ship into a points cloud by scanning. So this is a new development of digital twin or computer graphics and VR. And then it comes with differences between left-hand side, this is a real produced final product. In the middle, this is a CAD model. And right-hand side is a laser scanned point cloud. And they try to find out which one is missing or which one is correct as quality control. Oh, that's it already. Terima kasih.
All right, thank you so much, Prof. Hein, interesting
like this
presentations with a lot of videos. It's very impressive. Yes, anyone that you want to ask questions to Prof. Hein? Or I might want to ask you one question. Can I?
Sure.
Okay. How this the VR technology with digital twins that you already discussed in your presentation would be very potential and accessible to larger audience. I believe that it would be like limits to the industry, but how about the larger audience?
In larger audience?
Yeah.
What is right?
So meaning that the public can access on that.
I don't think about that one because I'm working on mostly on industry, engineering companies.
So it would be very potential for that,
Yeah, I saw that in the TV show. Because of the COVID pandemic, everybody stay home. So the BTS is very popular voice sound. BTS, the Korea band of sound, they could not make a world tour because of the pandemic situation, right? So instead, they provide this like online presentation of songs and band, right? And they use many different new technologies. So probably, yeah, VR.
One of the potential. All right. Okay, we have one question from one Muhammad Faiz, Professor Hein. How do you compare shipbuilding and aircraft building using the VR technology? How do you compare shipbuilding and aircraft building in VR technology?
Okay. Aerospace industry is very similar to shipbuilding industry. See, how can I explain in this way? One thing is, when I was in school days, more 30 years ago, the department of aerospace and shipbuilding was one department at the time.
Okay, right.
So you can see that there are very similarity. Right? Why is similar? Those are transportation system. Okay? Both are transportation system, and also it is big transportation system. Comparing to the building, the Petronas Twin Tower, they are not moving. Right? The building is not moving. That means the transportation system should be more closed system.
Okay.
Less connection to outside world. The footings, no footings. So that closed system means inside there are more interaction between them, between components, right? Compared to the static system. That is a difference. Another difference is an automotive car. That is also a transportation system. But difference is the car is relatively smaller. So that they can produce mass production. There is a big market and mass production. As I told you in my lecture, famous companies like Hyundai Motors, they produce 500,000 car per design. 500,000 car. One drawing, one design, the mass production. Otherwise, they can lose money. So their price is lower down because the mold. You are a chemical engineer. You can the door of a car is produced one time. One machine. We call this is a mold system. Molding. Big machine produce each door one piece one by one. So this mold is very big machine. Anyway, so they need mass production.
Right.
So coming back to your question, that VR is very well used in aerospace industry because the United States, they are forefront, top level aerospace engineering industry there. And also they have a technology for VR, so that they match VR high technology of VR, high level of industry there. So they use VR many times. But for the shipbuilding in the United States, there is no shipbuilding industry. Very small. So they work less VR application to the shipbuilding industry.
Okay, we have another question from Mr. Adi Maimun. How about application for virtual lab for students? How you can bring the virtual reality, the VR technology, to the students in the university?
Student, all right. this kind of online lecture is popular in these days. Every your school too, right? High school
Yes,
too.
yes,
All classes are online.
Mm.
The problem is the experimental classes.
Mm.
Chemical experiment.
Yes.
How can you provide online?
Yes.
So there is some difficulty to providing machining experiments in mechanical engineering, right? And cabling experiment of electronic engineering. So all the experimental classes has a difficulty rather than only lecture classes. Okay? So in that case, we may use more digital technology, something like VR.
Right. So it would definitely possible, right? Accessible?
I hope so.
In the future, I believe, because of the pandemic, everything is virtual at the moment. Okay, another question from Mr. Hui Xiang Kain. Thanks so much, Prof. Hein, for the lectures. How well do shipbuilding companies in South Korea adapt the VR technologies in their productions?
Oh, okay. Nowadays, shipbuilding companies are bad situation.
Okay.
All around the world, not only Korea, right?
Yeah, okay, affected.
Because of the economy and pandemic, right? Anyway, so that they need to have a more productivity, efficiency increase.
Yes.
So they try to use more digital technology. And one of them, they call the virtual shipyard. Virtual shipyard.
Okay.
Right. They are trying to, because as I told you before in the lecture, the shipbuilding is natively similar to construction industry. It is tailor-made, contract-based, only single production, not mass production. For the mass production, you need to have a very high level of maturity of design level. Design should be 90% complete before production. Otherwise, million of cars are mixed up. wrong production, right?
Yeah,
so
sure.
They need to have a high level of design level of maturity and then production. So it takes longer time. But for the construction industry, for the shipbuilding industry, only one design, one production. So that there is no enough time of level of maturity of design. That means what happens? There are many more design changes between and during the production stage, comparing to the mass production industry. So that you need more communication between production department and design department, because many details are found wrong in production stage.
Yes.
Right. So digital model can be helpful, VR or digital model, to communication, and also at the design stage they can verify before production.
That is quite brilliant. Okay, another question from Sahida Sulaiman. Sorry, quite a number of questions coming in, to be honest.
Good.
All right, thank you, Prof, for the sharing. What would be the challenges when the staff control the site onshore remotely? So suppose specific staff need to still go to the site in case of any issues that cannot be solved remotely.
This is very detailed question. I cannot answer.
What will be the challenges? Yeah.
When the staff
in your opinion,
onshore remote. Oh, it is question about the ocean plant.
Yes, because you show the one video, right? The everything you will be in the operation room,
right,
and then you just remotely control it. Yeah.
Right. This is very similar to something like a Navy ship. There is a patient happening. There is a battle. Somebody is dying. Very similar, right? Situation is coming.
Okay.
How can you solve that problem in old days, right? You need to send a helicopter there.
Yes.
Communication. They may turn in their route to the closest port, right?
Yes.
Whatever else, it is not Korea. It can be South America or Africa, but
Yes.
they need to find a nearby hospital.
Yes.
And then they call the hospital. They send a helicopter there. Right. Very similar situation, right? Depending on the how bad it is, right? You can send people or ask other people to help them. But communication is very important at the time also.
Right. In this sense, it means that the operations room would be for the convenience. But when the situation is critical, you definitely need to be there as well, right?
Right. Patient, right? Doctor, we need a doctor.
Okay, I think, is there any question so far, guys? Okay, there is no questions. It's kind of like probably once your collective summary, whatever that we already discussed today, with your lectures, the questions that is being sent by the audience, and what would be your collective summary for the sessions?
No summary, but I can send you the slide set to the Professor Rafiq and also Rafijiana, so that you can distribute to the audience so that they can see more.
Yes, it's very, very useful.
And I hope you to visit your sometime in the future.
Yes, you're welcome. Please visit me.
All right.
For the lectures, probably, yeah.
Right.
We make some arrangement after the pandemic is gone.
All right.
All right. Probably thanks so much, Professor Hein, for your valuable time giving lectures online, live telecast from our Facebook. So yes, back to you, Prof. Rafiq.
Thank you, Rafiziana, Dr. Rafiziana, for moderating the session and for introducing Professor Soonhung Han to me. And to our distinguished speaker, Professor Han, thank you so much for accepting our invitation to speak at our distinguished lecture series. And thank you for a great sharing session. And thank you for entertaining all of the questions from our audience. Just to let you know, Professor Han, that we have one program in naval architecture and offshore engineering offered undergraduate level here in UTM. So we really hope that we can collaborate UTM and KAIS as far as naval architecture, offshore engineering is concerned. And one more thing, we also have Marine Technology Center. That is one of our center of excellence here in UTM. We have a huge towing tank, one of the largest in Southeast Asia. And one of the questions was from the director of the Marine Technology Center itself, Dr. Henry Kang Hui Siang. So he posed a question to you just now. And then there was another question from Professor Adi Maimun, who also one of the members from the Marine Technology Center. So we have close to 200 viewers, Professor Han, for your session. And I believe that a lot of lecturers from the Marine Unit and Marine Technology Center also joined the session, your session today. So again, thank you so very much for your great sharing session. And to all our viewers worldwide, thank you for watching. Do stay tuned because we have many more interesting lectures for you. Until next time, bye-bye for now. Assalamualaikum. Bye-bye.
Thank you. Bye-bye now. Bye.